Alright guys, I here with you with types of variation. So like I explained in the previous video, we have different types of variation. I told you about that. I've already explained direct and inverse variation. Joint variation, we'll explain it. And I'm sorry, this is not going to be inverse. This is going to be partial variation. Okay, now looking at direct variation, you see I have these two arrows pointing up, these two arrows pointing down. What direct variation is that whenever a quantity is increasing here, whatever is related to that quantity, alright, will also be increasing. Okay? If this quantity is reducing, whatever is related to this quantity will also be reducing. So the two can move in the same direction. Either they are both going upwards or they are both coming downward. And mind you too, it could be more than two quantities, alright? It could be more than two quantities that are related to each other. Now look at this one. This quantity is going up while the associate is coming down. That's what happens with inverse variation. I just want you to understand the basics of how this works. Even though it's not going to be so much of an implication in the calculation, but just know how this works. And then why this one is reducing, this one is also doing what? Increasing. Okay, so that's it. So let's talk about direct variation now. Direct variation. In the other case, in the first example I was talking about, I was relating the cost of a cup of rice and the number of cups that can be bought. All right. So let's say that C. I told you that is a case of we consider that we consider speed and the distance that can be covered, right? Speed and the distance that can be covered. So the more of speed that you use, the more distance you will cover, right? So that means we can write this equation as S, that expression is S directly proportional to D. So we are saying that speed is directly proportional to D. Mind you, this S can be used to represent another quantity and D can be used to represent another quantity. But here we are representing this as speed and this as what? Distance. So whenever you are to write a direct proportionality, this is how you write it. Let's say P varies directly as Q. Alright, what this means is that as P is increasing, Q is increasing, or if P reduces, Q will reduce as well. So if you have this type of statement and you are to actually look for this is going to become simply you can write this as what? P varies directly as Q. You see the relationship? Yeah, that's the relationship. So that's the same thing we have up here. So I'll take this off because we actually want to work with this. This is speed varying directly as distance. So now that this is varying directly as distance, in mathematics we cannot solve with the proportionality sign. Okay, for us to have any case of variation, there will always be a constant. You remember that there will always be what? A constant. There will always be a constant. Remember when we did speed and distance relationship, we had a constant, all right, and the constant was 10 hours, right? So to bring in that constant, we write this whole expression as S equals to what? K and D. So here we have removed the proportionality sign. This sign is called the proportionality sign. So we have removed it and we have replaced it with an equal sign and what? The constant. Alright, so with this said now, we are now going to this becomes what? A relationship for us that we can use to solve any problem. Okay, so in the case where if the speed is equal to 200 kilometer per hour, okay, and the distance covered is 2,000 kilometer, then the question can be, we need to find k. That's the constant there. Alright, so this is quite simple. So all we are going to do is that we already have the relationship. So S is equal to KD. So instead of, so let me write, okay, let me just do this. S equals to KD. So speed is what? 200 equals K, which we don't know, times the distance, which is what? 2,000. So to look for K alone, K is now going to become equal to 200 all over 2,000. Okay, so that's it. So this now becomes K equals this will cancel this. You're going to have 1 over 10 here. I don't know if my camera covering that part of the board. Nope. So you're going to have that K here equals 1 over 10. Alright, so that's the constant. Alright, so that is simply what we have as this relationship. Okay, that is it. K is 1 over 10. Alright, so that's the point here. Okay, let's take something that's like a question and we deal with it from the beginning to the end. Okay, let me pause. Okay, this question on the board tells us that M is directly proportional to N. When M is 5,000, N is 50. Find M when N is 25. Okay, so this is what we are going to do. M is directly proportional to N. When N is 5,000, N is 50. Find M when N is what? 25. Okay, so this can be solved, right? So all we just need to do is to write this. M is what? Directly proportional to N. All this sentence, this one sentence can be written as this. Okay? Now, with this said, remember that our proportionality sign means that there is a constant value somewhere. Okay, so we are going to bring in the constant. Of course, we don't know what the constant is. So, but we are going to remove this proportionality sign and replace it with equals to Kn. Alright, we're using K for our constant. We can use any letter to represent the constant, but conventionally you always see or many times see that K is what is used as the constant. So I'm not going to digress. I'm not going to take a deviation from that. Yeah. So with this now, this whole thing now becomes, now remember they said when M is 5,000, N is what? 50. So M is what? 5,000. Then N is what? N is 50. So this means that if I put 5,000 here equals K times what? 50. Are you seeing that? So this whole thing will become that if I divide both sides by 50, K is going to become 5,000 divided by 50. Now if K becomes 5,000 divided by 50, this is cancel. 500 divided by 5 is what? 100. So wow, K is what? Is 100. Alright, so that means that there is a relationship that exists between K and N. So that means M is actually equal to 100N. Alright, so you could be asked to find the relationship between M and N. That's the relationship. Okay, the relationship is that M is equal to 100 of N. That's 100 times N. Okay, now that we have this, the question also says that we should find M when N is what? 25. Find M when N is what? 25. Okay, so here, M we don't know because that's what they ask us to find. But N is what? 25. We don't know, that's why we use this question mark for it. Okay, so with that said, that means that M is simply going to be 100. Remember? 100 because this is the relationship between M and N. 100 times N, which is what? 25. So by the time you do this, M is just going to be 100 times 25 will give you what? 2,500. So M becomes 2,500 when n is what, 25. Now if you look at this closely, you're going to see what we mean by direct variation. When m is 5,000, n is 50, right? See the value. Now n is now 25. That means n has reduced from 50 to 25. M now reduced from 5,000 to 2,500. Okay, so you see that proportionality there. Okay, so we're going to take another example, to relate to also work on this. Alright, so here is another question and we need to solve it. So we are given that P is directly proportional to the square of R. Okay, P is directly proportional to the square of R. So when P is 27, R is 3. Okay, so the question, they said find the relationship between P and R. And yeah, find R when P is 2, 4, 3. Okay, so we can do this, right? Yeah, sure we can. Alright, so let's move. P is directly proportional to the square of R. That's the first thing. So P is directly proportional to what now? R, no, the square of R. So R square is this. Okay, so this is just a simple deviation from what it should be. Alright, so but from here on henceforth everything remains the same. So now this will now becomes, I use the semicolon to separate one mathematical statement from another. So this now becomes P equals, the proportionality sign has to go and a constant has to be introduced, then KR squared. Now the question here, they said find the relationship between P and R. Okay, this is not the relationship now. The relationship between P and R is what we're going to find. But the question has already told us that when P is 27, we should find the relationship when P is 27 and when R is equal to 3. So P27 means we are going to have 27 here equals K times R. This is multiplication. K times R squared actually. So R is 3, then squared. Okay. So if you have that, that means you're going to get 27 equals K times 3 squared is 9. Okay, 3 squared is 9. But we're looking for K. So we need to find K. If we must find the relationship between P and R, we need to find the constant. Alright, so this guy is going to become 27. We divide both sides by 9. Over 9 equals K. So with this alone, K is going to be equal to 27 divided by 9 is what? 3, right? So you see that. So this is simple. This tells us that we now have the constant. So we can rewrite this expression as this. So P now becomes, we can rewrite this expression, I hope you see it, equals, instead of K, we now have 3R squared. So that's it. So this is the relationship. This answers the first question. Now the second question is that we should find R when P is 243. Okay, so P is 243 and R is the guy we don't know. Okay, so what we just simply do is we write 243 for P equals 3 times R squared. This is going to be what? R squared. So by the time we divide both sides by 3, we're going to have 243 divided by 3 equals R squared left. Okay, so we have that. So this will now mean for us that R squared will be equal to, I'm just translating this, so in the friend's direction, 243 divided by 3 is going to be 81. 81, that's what we'll get, right? Yeah, we'll get 81. But we are actually looking for R. So what do? We have to take the square root of both sides. So when you take the square root of this guy and take the square root of this guy, you get rid of the square here. So R, I don't know, R equals what? 9. That's not covered here. Okay, so I'm going to write it somewhere. So actually, I use this guy, I'll separate this. So R equals 9. You see that? So R is 9. So we have been able to do this proportionality problem, okay? So that's it. It's cool, right? It's cool. So that's the problem with direct variation. So from here you can do anything on direct variation and you will not have any problem. Okay, I'll stop here and we're going to take examples on inverse variation.